A proof is nothing more than just an explanation of why something is true. It's a logical argument. It's a deductive way of telling us how to get from A to B. That's all it is. Nothing more and nothing less. It's not some like scary monster out there. All it is just you explaining to me why something works. That's it. And in any one of these explanations, you'll be able to answer 3 questions. You'll be able to answer me and tell me, what do you know? What do you know? How do you know it? And why is it true? And if you complete any good mathematical proof in particular, you'll be able to answer those 3 questions. The what and the how, you've got plenty of experience with, especially in kind of the algebra universe, which is where we're going to start. You know a lot of the what and the how, and it will help you fill in some gaps as to explain very thoroughly why is it working, what's going on, and why is everything you're doing true, why does it work. Kind of where we're going to start pushing you in the direction today. There are 3 main formats, and we're going to look at 2 of them today. Right? The first is called a 2-column proof. This is the classic, the old dinosaur way to write a proof. This is the way people have been doing proofs. If you talk about a proof, your parents probably will know very intimately a 2-column proof. That's the old school way of doing things. And it's old school not because it's bad, it's because it's just the way things have always been done for a long time. Right? Your general format will look something like this. This is an outline. In the first box, we're going to write down this given means what are you assuming to begin with. What do you have? Just jot the information down. What is the information you're starting with that you're assuming to be true to begin with? We'll jot down in the proof section is basically your goal. All it is the goal for the end. So give yourself an endpoint, some focus, the goal. Or maybe your answer. This is where you'd answer. This is the answer to the question of what do you want to show? What are we trying to show is true when we're all done with this exercise? In the statements column, so now we have the 2 columns of the 2-column proof. In the statements column, we're going to fill in, say, all of your work or all of the steps. Steps to show your goal. And you be in, say, step 1, step 2, step 3, and however many steps it takes to get down to your eventual goal. I'm going to just list all the things that you're going to do. Okay. And the reasons, we're going to list why. Why can you do each step? So a reason for why you can say step 1. And then the next reason for why you can say step 2. The next reason why you can say step 3. And you'll keep going down until you run out of new steps because you don't need the reason for that. To me, or what I know is true from the beginning, what I have initially is this equation. 4x plus 7 is 51, is what's given to you. That's what you know ahead of time. That's what we know is going to be true to begin with. What's your goal? What are you trying to get to in the end? When you're done with all this explanation stuff, what should you end up with? X equals 11. Our goal is to show that if this is true, then we should be able to claim through, we can use like the law of syllogism, through all those fun stuff. We start here. Why does x equal 11? This is where we want to end up at. Okay? It's a goal mark. Well, how are we going to do that? The first step of most any good proof is going to be to lay out what you know. So my first statement is we start at the beginning. Four x plus 7 equals 51. Why does 4x plus 7 equal 51? Why do you know that to begin with?
That's the given.
Because that's what I told you. That's the given. So the reason why this is true is because I told it to you. Or it was given to you. Okay? That's our assumption. That's where we're starting. It's the basis. Okay. Well, knowing algebra, what would be something you'd want to do first here? What would be the next statement we would like to claim here? Isabel, what's something you'd like to claim? Next.
Like the next step and
Yeah.
solve it.
Uh-huh.
Minus or subtract 7 from 51.
Okay, so the do would be we're going to subtract 7 from both sides. Then after doing that, what do we end up with? Once you subtract 7 from both sides, what's the next statement that we'll make?
4x equals
4x equals 44. Would be a logical step we could make.
Can't we just plug x in to prove it?
Because we don't. Well, that's a good question. That's a good question. On a proof to show that something's true, to really deduce that it's true, to make a logical argument would be to maybe just not assume that's there, and then what would we end up with? Okay. So for the algebra things, I'm going to tell you specifically what to show. Then, sure, that could get you to where you got to go in algebra. But we're going to see, the goal is that when we transition to more geometric ideas, you're not going to be able to just plug in the final result to get to the beginning. So we want to show that we can work through all these through these reasons why they're true. Okay. Well, let's see. Our little work in between to go from statement 1 to statement 2 is what we subtracted 7 from both sides, and that gave us this. Okay. Since we subtracted 7 from both sides, the reason you could write a reason is, well, why did you get from here to there? I subtracted 7 from both sides. You could write that as a reason. A more formal way to say that, a more formal reasoning behind is why this algebra works, would be since I subtracted from both sides of an equation, then this would algebraically be called the subtraction property of equality. I can subtract two things from both sides. Would be the more mathematical reason for this. So I'm going to write for my reason, I'm going to write the more of a mathematical term. You could write, I subtracted 7 from both sides. This is the reason why I went from here to there. A more formal way would say subtraction property of equality is the name of this thing. Okay. So then now that we're here, we've logically gotten from step 1 to step 2. What's our next logical step? But we divide both sides by 4 and get the result x equals 11. And why are you allowed to claim going from here to here that x equals 11? Because you division. We divided both sides, so division. And if you're real lazy like me and you don't want to write property of equality, you can say division P of equality. Property of equality, you could abbreviate that stuff. Division PO. Property of equality. What next?
Done.
Oh. Yeah, we're at the end. We've gotten to our goal. That means you're done. That means your proof has ended. And if you want to feel like you're a mathematician, then to show that your proof is done, you'll put a little box and you'll color that box in. If you want to be a real mathematician way to do things, that's how mathematicians end their proofs.
Really? They put a box called.
Kind of a more modern way. We should be able to use what's called a proof map. And a proof map is nothing more than just a flow chart. It's a more graphical way. It's just a graphic organizer for making your proofs we'll say more visual. A proof map is going to be nothing. It's going to be it really is just a map. It takes us from A to B. It's going to be a much more visual way of doing things. These are most useful for when we have proofs that are going to require the things to be not just step by step. Or if you have, say, if you need to show like 2 or 3 different things in order to make a new claim. A proof map has the following format, and they'll look like this. Instead of having 2 columns, we're going to list our statements. We're going to list them as like a little mapping diagram, a little like bubble. And the reason why you can claim these statements, we'll write on the outside. We're still doing the same thing. We're still giving the same information. We're going to organize it in a little more visual way. So that when you make your statement and a reason, and then I want to claim something new off of that, I'll draw a little line down to my next statement. I'll connect statement 1 down to my next one, and I'll have the reason why that's true. And if I have another statement, then I'll draw a line and give me that number 3 statement, and then another reason. And I'll go off to number 4, and so on, and so forth. We'll just connect all these things together so that they flow down. If you want to organize them very vertically, you can. If you want to organize them horizontally, you can. If you just want to connect them from one to the other and you like jumping around, don't care, as long as they're connected. The connection really means where am I going from point A to point B as you go through. You can just kind of wander through your paper. You can start to the top and work your way, wind across, however you want to feel, but it's a diagram. It's a way to visually see what you're trying to explain.